history will record that America's challenge of today has forged man's destiny of tomorrow. And as we leave as we came, and God willing, as we shall return. Godspeed the crew of Apollo 17.
10, 9, 8, 7, ignition sequence started. All engines are started. We have ignition. 2, 1, 0. We have a liftoff.
17 Houston, you are go for orbit. Go for orbit.
America, Houston, this is America. You can breathe easier. America has arrived on station for the challenge ahead. Oh, are we coming in? Oh, baby. Okay, Houston, the Challenger has landed. We'd like to dedicate the first steps of Apollo 17 to all those who made it possible. Oh, my golly. Unbelievable. This has got to be one of the most proud moments of my life, I guarantee you. The words, our airman completed his first exploration of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind. When we look back at the Apollo program, I don't think anyone can privately to themselves or publicly say that this truly, indeed, has really been a beginning of man's really first venture out into deep space. And once there's a beginning, there's a continuation. A trip to Mars may not be for 10 years, a decade, it may not be till the end of the century. But I personally have faith that it will happen. And I think that the nature of mankind just press on. That's why I believe Apollo 17, yes, it's the beginning, but the whole Apollo program is really the true beginning of what's to come in the future. Godspeed and God bless you all.
Ladies and gentlemen, the President of the National Academy of Sciences, Dr. Marcia McNutt.
Good evening, everyone, and welcome to the National Academy of Sciences. I'm Marcia McNutt, President of the National Academy of Sciences. I'm truly sorry I cannot be with you today, but unfortunately, after 3 years of successfully dodging COVID, I too have recently tested positive. Therefore, this video greeting will have to suffice. Let me begin by extending a special welcome to our congressional visitors and staff. We thank you for your service to the nation. This evening, we are joined by leaders and heroes in the aerospace and science community as we salute our Apollo legends and celebrate the progress of the Artemis mission to return to the moon. Apollo 17 landed on Earth on December 14th, 1972 at 22 hours, 54 minutes, and 37 seconds UTC 50 years ago today. As we commemorate the past, we look to the future of space exploration. The Artemis program collaborates with commercial and international partners and establishes the first long-term presence on the moon. Then NASA will use what they have learned on and around the moon to take the next giant leap, sending the first astronauts to the surface of Mars. Robotic and human exploration allows us to explore and discover more about our solar system. The Artemis program takes advantage of this robotic human teaming with advanced reconnaissance by robots and a future human exploration enhanced by robotic assistance. For instance, the newly released Planetary Science Decadal Survey suggests a mission called Endurance A that would use commercial capabilities to deliver a rover to the lunar South Pole at Aitken Basin. The rover's long-range traverse across the largest, oldest impact basin on the moon would collect a substantial mass of samples. Astronauts could select the highest value samples and bring them home to Earth. The future of space exploration shines with successful endeavors enhanced and expanded by international cooperation, such as the James Webb Telescope and the Artemis program. We look forward to hearing remarks next from aeronautics and space luminaries in this evening's program. Thank you, and I hope you enjoy this evening's festivities.
We're going to the moon to explore, and we're going to the moon for scientific discovery.
Our destiny is always to go and see what's further and what's next.
The moon is a stepping stone, and the moon is a place we need to learn how to live so that we can continue to go beyond.
We are focused. We are focused on all that lies before us. Only together will we bring to life this global ambition of returning to the moon. And while our work is far from finished, we've never been closer to seeing a new generation step beyond our home planet. We are building on the achievements of those who came before. The giants who conquered gravity and raised a banner in the heavens, they beckon us to go farther, to the moon and on to Mars, to seek a deeper understanding of our universe and bring all that we learn home. 2020 was a year of unpredictable hardships, and yet, step by step, we resolve to press forward toward this grand vision. The daily efforts of thousands of suppliers from all across this country and around the world fed into stunning milestones and laid the groundwork for history.
Launch team, go.
Artemis has been woven into our culture. It has fostered collaboration across the aisles and across the ponds. It has grown beyond plans and preparations to include hardware and software. And now, it has a heartbeat. You can feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way.
Our mission to the moon is no longer some far-fetched dream. This is reality. We are going.
This is the next step in evolution.
They're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use.
This is real. This is going to happen. We're going.
We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
Ladies and gentlemen, the Administrator for the National Aeronautics and Space Administration, Senator Bill Nelson.
I wish Marcia could have been here, and I wish Jack could have been here, but I have talked to both of them about this evening. I spent an evening partially with Jack last Saturday at the annual astronaut holiday gala and dinner. And he was the speaker after dinner and spoke and answered all of the questions that continued to pepper him. Especially coming from the new crop of astronauts that we have, the Artemis generation. It was the Apollo generation. Now it's the Artemis generation. And You've already seen the beginning of the new beginning, and it has far exceeded in this test flight that we have stressed and tested this vehicle. Stressed it and tested it in a way that we would not do with a human crew on. And it went so well that we actually ended up adding additional tests during the course of the 25 and a half days. In thinking about the remarks honoring Apollo 17, and particularly Gene and Jack, I want to say that I ended up in a most unlikely place that you would think of space, Hutchinson, Kansas. I was out there to talk to a bunch of farmers about what NASA technology, and by the way, most people think of NASA as a space or aviation agency. A lot of people don't realize that we are a climate agency. Think about it. We design, we build, we launch, and then we operate a lot of those assets in space that are telling us what's happening. And one of those assets can tell a farmer the moisture content of the soil and what he ought to plant there, or the drought that's coming, or pick up the disease in his trees, in his forestry project that might be telling us something about future wildfires. And so I was out there visiting with the farmers, and here in Hutchinson, Kansas, is the Cosmosphere, an incredibly rich museum of space artifacts. And outside, as I entered, is a statue of Gene Cernan leaving those last footsteps on the lunar surface. It's a reminder to each generation that the story of humankind has always been linked to the exploration of the unknown. And there's a plaque there next to Cernan's statue. It's a quote from his speech on their departure. As I take man's last step from the surface, I'd like to say what I believe that history will record. The American challenge of today has forged man's destiny of tomorrow. And as we leave the moon, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Godspeed the crew of Apollo 17. Well, Artemis 1 has now just traveled 1 4 million miles through space, orbiting the moon, collecting data. And it's a fitting coincidence that Artemis 1 came home 50 years to the day after the crew of Apollo landed, of Apollo 17. And so the mission that we honor tonight, 17, we salute our Apollo legends and celebrate the progress now, 50 years later, that the Artemis mission to the moon has returned. It's a new generation answering the righteous call to go back to the moon, but this time not to be there and leave, but to stay, to learn, to live, to invent, to create, so we can explore on out into the cosmos, and we can go to Mars, hopefully by the decade of the end of the decade of the 2030s. The missions of tomorrow are being sparked by the accomplishments of the Artemis generation today. It's a new era of pioneers, star sailors, thinkers, and adventurers. And every observation we make, every lesson we learn from the first Artemis journey prepares the way for humans to venture even further. When Artemis 2 in a couple of years, and then Artemis 3 in about 3 years, launch astronauts toward the moon and to the heavens, they will answer the call of action from Apollo 17 crew. And Gene's comment that is emblazoned on a brass plaque on the Cosmodrome in Hutchinson, Kansas. It's time to learn what it'll take to establish a new community on a new cosmic shore, Mars. And the success of the first Artemis mission caps a successful year for us at NASA, to say the least. It's a year that started with the launch and deployment of the James Webb Space Telescope. Webb is now delivering unprecedented performance. It's delivering some of our deepest ever views of the early universe. And we expect to learn from it for at least 20 years. And every new image from Webb is a new discovery for humanity. Now just think, in a series of those very first photographs from the JWST, just think, we have captured light, infrared light, that travels at the speed of light, 186,000 miles per second. And this light has been traveling for 13.5 billion years. About 300 million years after the very beginning. And yet, we're going to continue to have these revelations. There's no rest. In response to the National Academies for Science recommendations, NASA is now starting work on its next major astrophysics project. The Habitable Worlds Observatory will search for potentially habitable planets around sun-like stars and then search for the evidence of life. The primary science requirement for this observatory is to achieve the contrast levels of 10 to the 10 required to image these planets around their bright parent stars. And we'll develop this new observatory, growing on the technologies that we have developed for Webb and the Roman space telescopes. But now we're going to benefit from the advancement of large launch capabilities with the successful launch of the SLS and commercial providers in the near future. And the Habitable Worlds Observatory will also baseline serviceability to provide a mountaintop capability. It will be enabled by the rapid growth in commercial satellite servicing. New logistics capabilities required for Artemis to operate in the cislunar environment are fueling these opportunities. What a year, what a year. And it's just the beginning. Now you think back, it's been 6 decades since 7 famous words reverberated through the Rice University Stadium in 1962, a few months after John Glenn had successfully orbited the Earth 3 times. And those words reverberated from that stadium across the country. We choose to go to the moon. President Kennedy knew that vision would be hard, not easy. He made that clear. He said, "We choose to go to the moon in this decade and do other things, not because they are easy, but because they are hard." He understood we still had to make major scientific and societal advances, but he also sensed something else: our country's can-do spirit. It's a spirit that drives us to make the impossible possible. And we came together over the course of this past year, after years and years and years of preparation and hard work, and we came together to do just that. So together, as Don Quixote reminds us, ladies and gentlemen, let's continue to dream the impossible dream that now becomes real. And let us traverse the untouched terrain of the once unreachable stars. Thank you. God bless you. And God bless Apollo 17.
Please welcome the curator of the Apollo Collection for the Smithsonian National Air and Space Museum, Dr. Teasel Muir-Harmony.
Good evening. On December 7th, Apollo 17 lit up the night sky at 12:33 a.m. It was a Thursday in 1972, and 500,000 people had come to Florida to witness this launch. But spectators as far away as Miami reported seeing the Saturn V streak across the sky. Walter Cronkite called it a spectacular sight. It was the first night launch of the Apollo program, one of many firsts the mission would achieve. Aboard the spacecraft were Commander Eugene Cernan, who had flown on Gemini 9A and Apollo 10, Command Module pilot Ronald Evans, an experienced naval aviator and aeronautical engineer, and Lunar Module pilot Dr. Harrison Schmitt, the first scientist to set foot on the moon. And 5 additional crew members. You can see one of them here, mice that the astronauts had nicknamed Fee, Fi, Fo, Fum, and Fooey. And these mice and Evans would go on to share the record of the longest amount of time in lunar orbit and the most lunar orbits traveled. But before Apollo 17 lit up the night sky and before the crew started their journey to the moon, hundreds of thousands of people spent hundreds of thousands of hours ensuring that the last mission to the moon would be a success. And one of those people was food scientist Rita Rapp. You can see her here. As the head of the Apollo Food System team, she ensured the astronauts would not only be nourished during their flight, but also satisfied with their food choices. Rapp joined NASA in the early 1960s. Trained as a physiologist, she conducted biomedical experiments, developed the Gemini medical kit, and then eventually took over the Apollo Food System team. Rapp and her team introduced huge improvements to space food, from using a water pistol to heat and rehydrate dry food, to following rigorous nutritional guidelines. But one snack she sent on the mission must not have appealed to the astronauts. Here it is, gingerbread cubes, so perhaps you can see why it wasn't so appealing. But it's a fitting dessert for a December mission. It went untouched, and the crew brought it back to Earth, and it's now housed at the Smithsonian with all the other space food leftovers. Another key contributor to the mission was Frank Pavliks, a Hungarian-born American engineer responsible for developing the lunar roving vehicle. After the Hungarian Revolution of 1956, Pavliks moved to the United States and took a position at the General Motors Research Division. It was there that he was tasked with the challenge of creating a tough electric vehicle that weighed less than 400 pounds. This is roughly the weight of a single astronaut in a spacesuit. On top of that, it had to be foldable and fit into the lunar module's cargo bay, and it had to be delivered within just 17 months. Pavliks and his colleagues met this deadline, creating a vehicle that boosted the astronauts' range and time to conduct science on the mission. So, well, the Apollo 11 EVA covered roughly the size of a football field. Apollo 17 explored an area roughly the size of Manhattan. In total, the Apollo 17 crew drove to 9 geological sites. They traversed over 21 miles, and they collected over 240 pounds of lunar samples. The lunar rover helped them make these achievements possible. Iona Allen also helped make these achievements possible. She was a talented seamstress at ILC Industries of Dover, Delaware, which had won the contract for Apollo spacesuits. She gained a reputation as being able to take on the toughest sewing challenges, including the lunar overshoes or boots. Gene Cernan's overshoes are shown here with traces of lunar regolith picked up from 3 long EVAs. After taking the last steps on the moon, he had the foresight to bring them back to Earth, and you can see them now at the National Air and Space Museum. Preparing for Apollo 17 required extensive training, from countless hours in mission simulators to practicing sampling in pressure suits at the Kennedy Space Center rock pile, you can see here, and geology field trips to places like Nevada. It also involved learning about orbital lunar geology from Farouk Elbaz, an Egyptian-American based at Belcom. Elbaz trained Ron Evans on how to look for color changes on the surface of the moon, since human eyes are more sensitive to subtle color variations than photographs taken from orbit. Elbaz also analyzed thousands of lunar photographs to select ideal landing sites for the Apollo missions, sites that would be both geologically rich and also safe for landings. For Apollo 17, geologists thought that Taurus Littrow offered the right combination of rock slides with samples older than those that had been collected on previous missions, and volcanic cinder cones that might contain younger material than what had been collected on previous missions. So on December 11th, Cernan and Schmidt conducted their first moonwalk. They deployed the lunar rover, they raised an American flag, they set up a series of scientific experiments, and they collected samples from Steno Crater. On the second moonwalk, they fixed their rover fender with an ingenious solution devised by Mission Control. They visited the Nansen crater, and then they took a core sample from the Ballet crater, which is pictured here. This year, NASA opened the vacuum-sealed core sample for the very first time. 50 years ago, they recognized that tools and techniques would mature, and in turn, we would have new ways of studying this material today. Near the end of the third and final EVA, Cernan and Schmidt spoke to 70 international students who had been invited to the Johnson Space Center. They described a rock they collected, pieces of which would be given to nations worldwide. Cernan explained, "We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind, that we can live in peace and harmony in the future." This sample became known as the Children of the World rock, and small fragments of it were given to countries throughout the world in 1973. This perspective that Cernan articulated was amplified by another gift brought back from the mission: the blue marble photograph. Although the ATS-3 satellite had captured an image of the whole Earth years before, it was this photograph taken by a human hand with this Hasselblad camera in the photo here that resonated so deeply that it became one of the most reproduced images in history. As Cernan explained, this image should be seen, quote, from a philosophical point of view. "This is us," he said. "We're looking at ourselves." The Apollo 17 crew collected invaluable lunar samples and data that have advanced our understanding of the moon and our solar system. But they also gave us a self-portrait with this blue marble image, one that offered us a perspective on Earth and ourselves.
Please welcome the Executive Vice President of Lockheed Martin Space, Mr. Robert Lightfoot.
Well, good evening, everybody. I'm thrilled to be here representing Lockheed Martin and humbled and excited to be taking part of this celebration for the 50th anniversary of Apollo 17. You know, before I jump in, I just want to share,
You know, when you're watching the video of Apollo 17, I don't know, I've seen a ton of Apollo videos in my career, in my lifetime. For some reason, that one felt pretty real. And I think it's because of the last month and a half, what we've been dealing with. For some reason, it just feels a heck of a lot closer. And the feel, I don't know if everybody felt that way, but it was pretty fascinating to think about it. Especially what we saw Sunday when we saw the 3 chutes. And I saw the chutes for Apollo 17. It's pretty amazing feeling. You know, this event really puts into perspective, you know, where we've been and where we're going. To start off today, I'm going to ask you to do 2 things. The first one you can do right away, and later we'll get to a homework assignment that I'll give each of you. First, I want you to take a moment and I want you to think about what all's been accomplished in space industry over the last few decades since Apollo 17. Of course, you know, we're all here to commemorate 17, and it was really just the end of a chapter. It wasn't the last thing that we did, right? We've landed on Mars multiple times. We had Hubble and James Webb take these captivating images of our universe. We developed and flew 135 space shuttle missions. We created an International Space Station and have been, if you think about 50 years since Apollo 17, 40% of those years have been there's been someone in space continuously on the International Space Station. So this past is what laid the foundation for the future where we are today, and these missions are what inspires the workforce of today. You know, for any of you that were at at what I'll call the landing events, as we call it, the landing parties from this weekend, we had one at Lockheed Martin out in Denver. The number of children that I know we touched as an industry that day was amazing. They were cheering, they were jumping around, they had their Artemis t-shirts on. They are the Artemis generation, and you could see it in their faces. It's remarkable to think about how our workforce alone, you know, when you look at, we have 5 generations of folks in the workforce today. And together we're developing the technologies we need. You know, lucky we're humbled to be part of this and part of some of our nation's most iconic missions and continue to be driven by the passion and the desire to explore the universe. One of those inspiring and energizing missions is one we're still captivating public hearts and minds. And I know all our hearts and minds, too, of the Artemis 1 mission. In addition to the spacecraft, we've worked to contribute to this mission in an inspiring way by leaning into our commitment to innovation and technology demonstration to move capabilities forward. We did that through the Callisto payload. I don't know how many of you interacted with that, but my team and we actually got together, and the Orion team got us together, and we actually talked to Orion as it was traveling in space. You know, you ask it where it was. You ask it how many more engine burns does it have? How many photographs has it taken? How far away from home is it? And it would talk back to you. A great way to interact with using technology from Amazon, Cisco, to do that. You know, we worked those technology, brought that commercial technology to test it out, and it may be needed and may be used for deep space exploration. What a great example, though, really, when you think about it, how we could use that in the crew module. The drive to explore new frontiers is central to who we are as human beings. And the space sector has always been fueled by the urge to invent and what we need to see over the next horizon. So going back to the homework assignment I mentioned. When you get home, if you have one, ask your Alexa, take me to the moon. You'll see it's a whole new way for us to connect to those missions. And I can tell you I've had a lot of fun doing that with my grandkids. And what I want to share with you is the book of exploration, the way I think about this, right? The book of exploration is mostly unwritten. There's a chapter for Apollo, and Apollo 17 is the last part of that chapter. There's a chapter for Shuttle. There's a chapter for International Space Station that continues to be written. There's a chapter for the great observatories we've put up. But the chapter for Artemis is just getting started. And what I can tell you is the people that have that pen and are writing it, we can all be very proud of, because that's the next generation that's going to stand on the shoulders of the Apollo giants and really develop humankind's ecosystem for space exploration. Thank you for being here, and have a great time tonight.
At NASA, we have always answered the innate call to go.
With Artemis,
we are going to stay.
Proving that humanity
can live on the moon
Mars,
and other worlds.
and share the wonders of the solar system with all.
Our story is one of people.
All those who make this journey possible.
From advocates across communities,
to companies across industries, to countries around the world.
We achieve this collective endeavor.
our efforts create impact for all.
Technologies that revolutionize industries.
And jobs that bring prosperity to people.
The discoveries from space
benefit the way we live on Earth today.
And those from the moon
will create a better future
for generations to come. But to do that,
we must go.
Hi, I'm Shel Lindgren.
My name is Raja Chari.
Kayla Barron.
Kate Rubis. Hi, I'm Christina Cook.
NASA astronaut Joe Acaba.
Jessica Amir.
Woody Hoberg.
Anne McClain. Stephanie Wilson.
My name is Johnny Kim.
Nicole Mann.
Victor Glover.
Jessica Watkins.
Hi, I'm Matthew Dominic.
Jasmine Mogbelli.
Frank Rubio.
Scott Tingle.
This is what we do.
This is what we will do.
Let's go.
We go to the moon to learn how to live on other planets.
For the benefit of all.
Please welcome former NASA astronaut, Mr. Leland Melvin.
Hello, I'm Leland Melvin, engineer and former NASA astronaut. Now, being the first takes bold vision, great courage, and unshakable faith. It is the pursuit of a new path and the exploration of uncharted territory. The first take on the highest risk and often experience the greatest obstacles. They question conventional approaches, encourages new ideas, and commits to action even in the most uncertain situations. And when you're the first, you will be amazed how the world responds. Now, most of you don't know that I was the first astronaut to be drafted into the NFL. You probably thought it was NFL player and American TV personality, Michael Strahan, right? Now, while Michael and I were both drafted in the NFL, I was the chemistry nerd who received an age-inappropriate, non-OSHA certified chemistry set where I created the most incredible explosion in my mother's living room, and that fueled my curiosity for science. And after college was drafted by the Detroit Lions and later became the first NASA astronaut to have flown in space. Now, behind many firsts is always an incredible story. And Artemis will mark NASA's first mission to land humans on the moon since Apollo 17 in 1972. The Apollo mission touched the populace and set out a pathway that led to the success of many missions. It required vision, commitment, and the tenacity to take us where we had never gone before. Now, like the Apollo mission, the Artemis team of astronauts will be called upon to meet another first in the highest level of scientific and space exploration achievements, preserving and improving human existence, life beyond the Earth's core. The Artemis team, a mosaic of different cultures, skills, and levels of expertise, will bring together a vibrant exchange of human perspectives and viewpoints. Its mission will reaffirm the global relevance of the link between diversity, defined as a greater proportion of women, and the cultural composition and integrated knowledge of experienced scientists, engineers, and researchers. Now, through these fascinating Artemis missions, the first woman and the first person of color will land on the moon. Another significant first. Now, that's reflective of the world we live in right now. This strong scientific enterprise like any resilient system, aims to deliver and embed human-centered design methodologies so we all can benefit from new system technologies in aerospace and learn new methods for sustainable change. Now, this diversity is a source of our strength, and it's an engine of expansion and innovation. The Apollo team had to rise to many challenges and embrace many changes. They had an outsized impact on progress, and our Apollo heroes, Eugene Cernan, Ronald Evans, and Harrison Schmitt, ensured we were incredibly prepared. Over time, systems evolved. And the Artemis team will use the outcomes and success of the Apollo mission and others to maximize global impact in the most meaningful way. Now, while we may not know which Artemis astronauts will join the ranks of aerospace first, the pioneering spirit lives on. Those selected will become our newest trailblazers, who will continue to inspire us and the next generation of explorers to see beyond where we are today. Discoveries that will go beyond history, the start of a new era, and the possibilities are without limit. So we thank you, Apollo missions. You were the first to build a legacy to those in the world you are called to serve. Job well done, Space Brothers. Godspeed, Artemis sisters and brothers.
Hey, I'm Dr. Brian Odom. I'm the NASA Chief Historian. It's a thrill to be in here in front of you guys today. But as you know, Harrison Schmitt, unfortunately, not me, but Harrison Schmitt, was supposed to be here today. But due to a conflict of schedules, he was unable to do that. But he did have a chance to reach out to his NASA friends and share some messages about the importance of the mission, the importance of lunar science, and what we might expect in the future.
No matter how much preparation you have for experiences like stepping on the moon, it's going to be more than you ever anticipated.
Schmitt was the first trained field geologist to observe the moon up close and personal, and he found himself discovering unexpected things with every step.
Every rock that we examined had something new that I didn't expect, and surprises is what geologists like. That's why you're exploring, is to see the things that nobody's ever seen before.
Schmitt spent a combined 22 hours outside of the spacecraft during his 3 excursions on the moon. Before his own trip, Schmitt trained other Apollo astronauts, sharing with them his in-depth knowledge of fieldwork.
The main thing was to expose them to as many different, say, geological experiences as we possibly could. Get them out in the field. Don't let them sit in the classroom.
He treated training scenarios on Earth the same way he would if they were on the moon, including simulated equipment, backpacks, and cameras strapped to the front of spacesuits. Astronauts could then focus on what differences in the rocks they were seeing and what rock samples were best to collect, essentially giving them the fundamental field geological experiences that they needed to succeed. The 4 or 5 days per month Schmitt spent training astronauts in the field really did make a difference.
The quality and diversity of the Apollo sample collection, independent of Apollo 17, where you had an experienced geologist, the quality and diversity of that sample collection is just remarkable.
Fortunately, the current Lunar Reconnaissance Orbiter mission, or LRO, is changing the game, bringing back high-quality photography of the moon that Schmitt only wished he'd seen before his own trip.
The Lunar Reconnaissance Orbiter program now has provided us with a much, much higher resolution suite of photographs for any future astronauts.
What we learned from the Apollo missions helped lay the groundwork for LRO, and LRO will help guide future explorers.
Every new environment in which a geologist works is usually very different than the last, but you have learned things from your previous experiences that do in fact enable you to maximize the value of your new experience.
Schmitt has his fingers crossed for future moon exploration, a landscape he considers holds answers to many questions about the early solar system.
You can hear people talk about it, but you can't absorb it until you're there.
Please welcome the Deputy Administrator for the National Aeronautics and Space Administration, Colonel Pamela Melroy.
Thank you. Thanks so much for joining us to celebrate the Apollo 17 mission. In the many ways, I think what I'm excited about talking about tonight is the science and the impact of the science of Apollo 17 and how that stretches forward into the space program today. So I'm very passionate about this. But at first, I have to thank Marcia McNutt, the National Academy of Science, for hosting us. A special thank you to Colleen Hartman and your staff for organizing this. And thank you to our other speakers and everyone in the room. And thanks to our primary sponsor, Lockheed Martin, as well. I think as this program shows, and as Harrison Jack, as I will call him, those who are close to him, just told us there's a lot left to do. And that is nowhere more true than in science. One of the things that I loved about those videos we watched, you can really hear the enthusiasm in the scientist's voice and the astronaut's voice as they're talking about seeing things for the first time. The thrill of it, what they're experiencing. One of the things that was interesting about being a part of the cadre of astronauts that built the International Space Station was that as we added each element, we also added new camera views. And every time we added something to the space station on an assembly mission, we had our minds blown. We saw the station from a different point of view. We saw the shuttle from a different point of view. We saw the Earth from a different point of view. And each step really gave us a new lens to look at what we were doing through. You can really see some of that enthusiasm and that amazing sense of having a different lens from the most recent Artemis 1 mission. The pictures that we recovered from the moon, we've taken pictures of the moon before, but how long has it been since we saw live from the moon? And the views involved the Orion spacecraft. That was a view we've never seen before. It was just incredibly moving and inspiring to feel that we have this new lens to look through and how much we're going to learn about the moon as we go on this trip. For me, the Apollo missions were personally very inspiring. The Apollo missions were what inspired me to decide to become a scientist and an astronaut. Yes, it's actually true. I am a test pilot, but my undergraduate degree was in physics and astronomy, and I have a master's degree in planetary science. It's been a long time since I'd done it. But I was very, very inspired by the idea of visiting other planets and exploring them. In many ways, Jack was my hero. On Apollo 17, we saw the groundbreaking science that could happen when you sent a trained scientist to the surface of the moon. Now, I happen to be married to a professional geologist, so I know the limitations of how far I can go as a test pilot. I love science and I'm passionate about it, but there is nothing like the eyes of a trained scientist. And in many ways, that kicked the door down when you look at what we did on the space shuttle to the diversity of backgrounds and experiences, bringing professional scientists and not just test pilots as astronauts. I think it transformed everything that we have done since, and Jack was the first to do that. He not only helped the science outcomes on the Apollo program by training his fellow astronauts, and of course on Apollo 17, but he actually was deeply involved in forging lunar science after his mission, and was very, very engaged in the community. That lunar science is paying enormous dividends for us today as we prepare to go back to the moon. The Lunar Reconnaissance Orbiter was mentioned in the video, and that continues to be our eye in the sky. We need to start thinking about even higher resolution pictures. I'm looking forward to that. I think that's going to be important to exploration. And of course, Capstone, our first CubeSat to orbit the moon, it's charting a very unique orbit. One of the interesting things about the science that we're going to learn on Artemis is that it is not just about planetary science, although I'll talk a little bit more about that. But one of the things that I think is particularly exciting is the capabilities in other disciplines, such as astrophysics and heliophysics, that we can do from the moon. The science accomplishments of Apollo 17 specifically are many. We continue to learn from all the Apollo samples. I was delighted that we opened the Apollo 17, the last sample, because it means we have to go back and get more. That's good. This mission was particularly noteworthy, though, thanks especially to Jack Schmitt. A 4.2 billion-year-old sample. Incredible. That is just, I mean, it's almost impossible to fathom because, of course, it's the history also of the Earth, the moon and the Earth system. Evidence of the moon's volcanism. That was a big shocker. There were a lot of experiments that focused on some subtle areas that I think we have much more to explore, particularly soil mechanics, seismic profiling, and of course, orbital science, as I mentioned. Science is really one of the main reasons we're going back to the moon. It's foundational to why we go to space, is to get a unique perspective, science that can only be done from space and from exploration. James Webb, of course, being a classic example. We can only see in those frequencies at that in that particular manner, deep back into the history of the cosmos by being in space. But in addition to that, we cannot learn about our solar system and about the Earth-Moon system and the environment around it without visiting. But there's a lot more to do. So when the first woman and the next man set foot on lunar soil, they're going to have a wealth of much more sophisticated tools at hand. So we will try to pre-deliver technology that will amplify and enhance the science mission. And we're going to have other payloads that are going to help them become scientists in residence and pick up that torch from Jack and from Apollo 17 and all the other pioneering missions that enabled us to envision the future. One of the things that I'm particularly excited about is the capability for human-machine teaming. So I think we're just barely scratching the surface here terrestrially. So I think we can actually advance the bounds of science, not just in space, but actually here terrestrially, by amplifying and learning how we can use machines and humans together to travel places we couldn't go to before and do world-class science in situ, where we recognize that machines can do things that humans cannot, and humans can do things that machines cannot. So we'd like to really take advantage of that unique capability going forward in particular, and we hope also to take advantage of citizen science. As I mentioned, science is at the forefront of our Artemis missions, and we're going to be doing this internationally. I think I'm very proud. I love the shot of the world rock that Teasel showed us, the children of the world. Is that what you called it? Because we shared those lunar samples around the world, both for their inspiration, but also for their science. Now we plan to go with nations large and small. And that's really important because I like to say, since we're staying, how we go is as important as what we do when we get there. And by going in partnership with an international community focused on transparency and focused on science, that's the future that we want for humans in space. That will make a huge difference. We'd also like to send more geologists like our astronaut Jessica Watkins and this is not a preview, but I do know who all the geologists are in the astronaut office. They really bring an extraordinary point of view, but it's not just our geologists. Of course, we're doing other kinds of science as well. And I'm thrilled to see the diversity of the scientists in the astronaut corps and see how they are going to contribute in new ways to the science on the moon. I'd just like to touch a little bit on what we think we might be able to achieve in lunar science. We hope to do fundamental planetary science in line with the recommendation of this spring's Planetary Science Decadal Study performed by the National Academy, which of course is the guidepost that we use for science going forward. That report stated, the advancement of high-priority lunar science objectives should be a key requirement of the Artemis human exploration program, and I'm happy to tell you that it is. Now, in the 50 years since humans visited the moon, there have been new advances arising from our lunar robotic missions, but reanalysis of older data, modeling, and intensive sample analysis, again, over the years with increasing capability. These have produced dramatic results and new questions about planetary volcanism, and in particular, volatiles on the moon, impact processes, tectonics, and the lunar environment overall. So, our Deputy Associate Administrator for Exploration, Kathy Kerner, said the other day to me, and it really hit me hard. She said, you know, the moon probably hasn't changed a lot in 50 years, but boy, have we. We have changed a lot in 50 years in our capability. And now we have those new capabilities. We also have a new resolve. We have a new mission to stay, to learn, to develop a blueprint for how we're going to do science with humans throughout the solar system. We're going to practice it on the moon. We're going to go demonstrate it on Mars. And then I hope that there will be a deputy administrator standing up here in 10 years telling you where the next destination is going to be. Apollo gave our nation and the world new capabilities. Our space program's current rapid progress has strengthened our aerospace base. And today, we send astronauts to space aboard commercial rockets. And our innovative industry and international partners are joining us in a return to the moon that will enable us to take the work of Mercury, Gemini, and Apollo teams to the next level. And it's going to be for the benefit of science and for the benefit of humanity. All of us tonight benefit from perhaps the most important gift of Gene, Jack, and Ron, the Apollo 17 mission, and the huge teams that made that mission and the entire Apollo program possible. And that's the inspiration and the will and the belief that we can pursue things that have never been done. We said we were going to do it, it seemed impossible, and we did it. And I think that is the unshakable spirit of the American people, but also of NASA, but I think actually of human nature. We say we're going to do it, and then we go do it, to find in ourselves the strength and the resilience and the resources to reach higher and achieve the impossible. As the future Artemis generation, we're going to take that gift, we're going to pass it on, we're going to continue the exploration of the solar system and the cosmos, and discover science that we cannot even conceive of right now. We'll do you proud, Apollo 17. Thanks for being here.
Please welcome the National Academy of Sciences Director of Physics, Aeronautics, and Space Science, Dr. Colleen Hartman.
Good evening. I'm very honored to close out this star-studded event, and many thanks to these speakers for an incredible journey. Thank you. This nation's past achievements will be built upon a new human-robotic partnership, as Pam just said. But I hesitate to give this esteemed audience any concluding advice. I realize that giving advice is a thankless business, and I assure you I shall not venture far in that direction this evening. I've always kept in mind the unconsciously profound summation written by a young schoolgirl. Socrates, she wrote, was a Greek philosopher who went about giving people good advice. They poisoned him. Today's speakers prove that we stand on the shoulders of giants, setting out on the threshold of a new adventure that will transform not only our understanding of the physics of the universe, but also humanity's place in it. Our very special thanks to our night sponsors, Lockheed Martin, for their generosity. I also want to thank an amazing and incredible group at the National Academy of Sciences at NASA headquarters who worked tirelessly bringing this effort together. Very many thanks to Lisa Frazier, Cindy Steele, Lauren Katz, Michelle Barth, Eli Nass, and from the Academies, Hunter Moore, Megan Chamberlain, Linda Walker, and a very special thanks to our own Andrea Rebholz. Just please join me in a warm round of applause for those who made this possible. Thank you for attending, and now you are all most welcome to join us in the Great Hall. Good evening.